Another type of construction you might run into when you're thinking about word problems are ordered lists. So let's say you run into a question that involves an ordered list or a sequence of objects. That might look like coordinate pairs, or choice of an appetizer, main dish, or dessert, or binary words of length k, that is, sequences of zeros and ones. Some key words that signal to you that you have a list or a sequence of objects are list, sequence, or pair, triple, tuple, a word, or independent choices. All of those words are telling you that you have a list or a sequence of objects. So how does that relate to sets? Ordered lists are Cartesian products. We have to figure out what's the set of possibilities for each entry in the list. What are the possibilities for the first entry? What are the possibilities for the second entry? What are the possibilities for the third entries? Each of those is a set. Then we take the Cartesian product of these sets. Let's look at this first one, coordinate pairs, x, y. X, y are often points in the xy plane. X can be any real number, y can be any real number, and so our set is the Cartesian product of r cross r squared. Now let's look at this second example. You go into a restaurant and you have a choice of an appetizer, main dish, and a dessert to fill out your meal. We look at the menu and we see the set of different appetizers we could have. We then look and see what the set of main dishes are. And finally we see what the set of desserts is. And then the set of possible meals is then the Cartesian product of the set of appetizers times the set of main dishes times the set of desserts. Last, let's consider these binary words. In a binary word, the first entry is either 0 or 1. The second entry is either 0 or 1. The third entry is either 0 or 1. Every single entry up to the kth entry is 0 or 1. And so we can write this as 0, 1, cross 0, 1, cross 0, 1. This k times Cartesian product. Or we can write this as 0, 1 to the kth power. Let's say instead of sequences, we have a question that involves subsets of a larger set. For example, what subsets of the colors red, white, and blue can appear on a country's flag? A set of subsets is the power set of your set. The answer to this question would be the power set of the set red, white, blue. You could have no colors. You could have red on the flag. You could have white on the flag. You could have blue on the flag. You could have red and white on the flag. You could have red and blue on the flag. You could have white and blue on the flag. Or you could have all three, red, white, and blue on the flag. One more example. What are the possible sets of positions in which a 1 can appear in a binary word of length k? 1s can appear in any of the positions, position 1 or position 2 or position 3 up to position k. So 1s can appear in any subset of those positions. Right? 1, 0, 0, 1 is a 1 is in positions 1 and 4. So the answer to this question is the set of all subsets of 1 up to k. In other words, the power set of the set 1 up to k. That's it for this video. One more video to go. See you there.